Okay. Last class में we were doing the empirical formula and we solved this question. So let's revise. Empirical formula में क्या होता है? The first step is in every question they're either going to give you the percentage mass or the mass itself. So in this question they've given you the percentage mass. So carbon they've given you as 85.7. And hydrogen they gave you as 14.3. So what you do is you divide each of the percentage masses by its own AR. So 85.7 divided by carbon's AR, that is 12, and 14.3 divided by hydrogen's AR, that is 1. When you get each answer, for example, here you got 7.14, and in the second one you got a 2. So you divide each of these numbers by the smallest number. So say 7.14 14.3. So you divide both of these numbers by the smallest one, that is 7.14. So 7.14 divided by itself is going to give you 1, and 14.3 divided by 7.14 gives you 2. So 1:2 is your smallest whole number ratio for carbon to hydrogen. Okay? So you get a CH2. Is this clear?
Yeah.
Okay. Let's do one more example if I can find another question. We did this for CH2. Acha, let's do a question on the molecular formula. So we're done with empirical. Empirical was the simplest whole number ratio between atoms. So if this is my empirical formula, this can be my molecular formula. और molecular formula कैसे आता है? This is a formula for your molecular formula, and here N is what? N is a whole number, which is molecular formula mass over empirical formula mass. So let's do a question just where we find out the molecular formula so we know how to use this formula. The empirical formula of X is C4H10S, and the relative molecular mass of X is 180.42. And they're asking us what is the molecular formula of X. So what do we know about X? In this question, let's extract the data. So we have the empirical formula that is C4H10S. We have the molecular mass that is 180.42, and they are asking us for the molecular formula of X. ठीक है? अब relative atomic masses क्या है? Carbon ka is 12, hydrogen ka is 1, sulfur is 32 or 32.07 to be very specific. So to find out N, what do we need? Molecular formula mass and empirical formula mass, right? They've already given us the molecular formula mass. Let's take out the empirical formula mass. Empirical formula mass कैसे आएगा? If this is the empirical formula, तो इसका mass निकालेंगे तो empirical formula mass आ जाएगा. So step 1, calculate empirical formula mass. Empirical formula has been given to us as C4H10S. So it's 4 into 12. plus 10 into 1 plus 32 into 1. ठीक है, अब इसको टोटल करेंगे तो we'll get the total mass of our empirical formula. The total turns out to be 90.21. 90.21 क्या है? Empirical formula mass. Moving forward, how do you find out N? N is molecular formula mass over empirical formula mass. So molecular formula mass दिया हुआ है as 180.42. So step 2 is to calculate N. And N is molecular formula mass over empirical formula mass, 180.42 over 90.21. ठीक है, इसका आंसर आ रहा है 0.42 divided by 90.21. Exact answer आ रहा है 2. So N turns out to be 2. Now we have N. Going back to the formula, what do we need to do? अगर N हमारे पास 2 आ रहा है, we just multiply our empirical formula with N to get the molecular formula. So empirical formula क्या है? C4H10S. Step 3, empirical formula into N. So H10S into 2 because N is 2. And how do you multiply it? So this is 4, C4 into 2, H10 into 2, S 1 into 2. So it's C8, H20, and S2. This is your molecular formula for X. ठीक है? Got it?
Okay.
Okay, do you want to do another question on this? Or is
Yes,
this
please.
fine? Okay, wait, let me search up another question on the internet. Hmm. Okay, so this is a question here. So the question states the percentage composition of an unknown substance is this much. If its molar mass is 333 gram per mole, what is its empirical and molecular formula? Now, this is not from the past paper, so I'm not sure of the answer, but we will still solve it. So we have carbon, hydrogen, nitrogen. So for carbon, we have 75.42. Hydrogen के लिए we have 8.38. Nitrogen के लिए we have 9.57%. First step क्या होता है? Divided by the element's own AR. So you divide this by 12, divide this by 1. Nitrogen का AR क्या होता है? 14. So we divide this by 14. So 75.42 divided by 12 gives us 6.285. 8.38 divided by 1 gives us 8.38. 9.57. We are not getting whole numbers here. इसका तो answer ही less than वो आ रहा है, 1. I think I'll pick up a question from the past papers. Wait. Molecular and empirical formula. Okay. So this is the question. Empirical formula दिया हुआ है, relative molecular mass दिया हुआ है, and they're asking you for the molecular formula of X. Empirical formula is C4. It's the same question. Oh God. Hydrated copper sulfate crystals. Okay, let's do this.
Miss, can you go back to the question for 1 minute?
Sorry,
Can you go back to the
here.
question for 1 minute?
This one,
No, the other one that you just put.
the one I just removed.
Yeah.
It was the same as this one. That's why I removed it.
Okay. Can I just write the question for 1 minute?
Okay. Are you copying it?
Yeah.
Okay. Let me know when you're done.
Miss, can you scroll down a bit?
Yes.
Miss, can you scroll down a bit more?
First, end of the question.
Okay, okay.
Okay. So are you done? We can start with the other one.
Yes.
Okay. So this is one question that I'm solving. After this question, I'll give you another question that you will solve. Okay.
Okay.
So a compound contains 40% carbon, 6.67% hydrogen, and 53.3% oxygen. The molecular mass is 60. Calculate molecular formula. So here we have carbon, hydrogen, and oxygen. Carbon, hydrogen, oxygen. First step is to divide each percentage by its AR. So carbon is 40 divided by 12. Hydrogen is 53.3 divided by 1. Sorry, this is oxygen. Hydrogen is 6.67. And oxygen is 53.3 divided by 16. So the answers that we get after dividing, each one of these are 3.33 for this, 6.67 for this, and 3.33 for this again. So the smallest number is 3.33. So let's divide each number by 3.33. We get 1. We get 1 here as well. And here we get 2.003, which is approximated to 2. So what's the simplest ratio that we have here? C1,
1,
H,
2, 1.
and 1, right? So CH2, CH2, and O. So yeah, this is our empirical formula. We need to find out molecular formula. So molecular formula कैसे निकालते हैं? Empirical formula into N. And N निकालते हैं molecular formula mass over empirical formula mass. So molecular formula mass has been given to us as 60. Empirical formula mass we will find out by adding the ARs of each of these elements. So carbon 12, hydrogen is 1 into 2, oxygen is 16. The total turns out to be 12 plus 2 plus 16. This is 30. So let's input it into n. So n turns out to be 2. So empirical formula into n gives us molecular. Empirical formula is CH2O, n equals 2. So molecular formula turns out to be C2H4O2, right? You get it?
Yes.
Now I'm going to write the next question and you will be solving it. A chloride of iron contains 34.5% iron. The molecular mass is 325. Find molecular formula. Now, before you start off with this question, I'm just gonna clear up one thing. This is a chloride of iron. So a chloride of iron is FeCl, right? Now this can be Fe2 plus, Fe3 plus, whatever. So I just assume it to be FeCl2. So this means that this compound has iron and chlorine. So Fe and Cl, they've told you the percentage of iron, 34.5. So chlorine's percentage will be
The rest, 100
exactly.
minus 4.5.
Exactly. So this is how you're going to move forward with the question. Okay? Now
Okay.
you may continue.
Miss,
Yes, yes.
what's the atomic number of iron
Iron
and
is
chlorine?
56.
And chlorine?
Chlorine is 35.5. So this is 56.
Okay, thank you.
Okay.
Miss, I'm done.
Okay, what's your answer?
Fe2Cl6.
Perfect. Correct answer. Just gonna complete this. Either you have and for N, you need the empirical formula mass that is 56 plus 35.5 into 3, which gives us 106.5. So N is 325 or 106.5 and turns out to be 2. So FeCl3 Okay, perfect. Now let's start with molar concentration. So what do we mean when I say molar concentration? For example, I have a cup of water, and this is about 10 centimeters cube of water. And I add 10 grams of salt, that is NaCl, to this. And then I ask you, what is the concentration of this solution? So the concentration will be the amount of solute over the amount of solvent. So solute is what you add into the solution, and your liquid to which you're adding it is called the solvent. ठीक है?
Which one was solute again?
Sorry? Repeat.
Which one is solute?
Solute is the thing that you're adding. This is solute. And solvent is the liquid that you already have. This is your solvent, and your salt is your solute. Okay?
Okay.
Okay. Now, when we're talking about the concentration, so concentration ke baare mein we have a formula which is solute over solvent. Now, this can either be in moles, meaning how many moles of NaCl I'm adding, or I can say how many grams of NaCl am I adding. Now, back to the formula where I said, here, first let me introduce you to this formula, which is number of moles equals concentration into volume, which is also concentration equals number of moles over the volume. This is the same as this equation, meaning when we're talking about volume of the solution, we're also talking about the solvent, right? It's the same thing. So basically, denominator में we're going to write the volume, which is 10 centimeters, and numerator में we have the solute. So we can either write moles of NaCl or we can write NaCl in grams. Okay, so N here means moles. So moles over the volume gives us concentration. Say it.
Okay.
Now on to notes. Concentration of a solution is the amount of solute dissolved in a solvent to make 1 dm cube of solution. Concentrated solution is a solution that has a high concentration of solute and the opposite of a concentrated solution is a dilute solution that has a low concentration of solute. So these are the 3 units in which you can express concentration. So it's either moles per unit volume, it's mass per unit volume, meaning grams over volume, or parts per million. Parts per million is used for very smaller amounts of solute. For example, if we're counting the pollutants in air, so pollutants की concentration compared to the air around you is very much lesser, right? So when we're talking about parts per million, it's usually for lesser quantity of solutes. ठीक है? I'm going to keep it till here for this class because next class के लिए we'll start with the worked examples. Other than that, I think I'll give you a few questions on empirical formula for homework and I'll probably send them right after class. Okay. So next class se pehle, it's also going to be revision for
Oh,
your quiz. Okay.
okay.
Okay. Any questions from today's class?
No.
Okay, perfect. Okay, so I'm going to end the class and after class, I'm going to send you a PDF for empirical formula questions.
Okay.
Okay. See you. Take care.